And here we are, continuing to practice with finding zeros, because that's hopefully giving you a hint that zeros are kind of important when it comes to polynomials, but also just math in general. But the other thing we're going to really focus on today in this video is irrational zeros and trying to recognize a pattern. First, we need to think about what are irrational zeros. Well, irrational zeros are zeros that are irrational numbers. So remember, irrational numbers are things like the square root of 2, the square root of 11, the square root of 10, pi. So things like those are irrational numbers, as opposed to the square root of 4 is 2, so this is not an irrational number. It's a number, it's a real number, not an irrational number. So it's actually what we would call a rational number. All right, so this is irrational. Anyway, let's move on. So I want you to find the zeros of the function for each of these polynomials below, and then write them in completely factored form. My hint, remember that you are going to first set it equal to 0. I believe you can do this for both of these, so pause the video, find the zeros, unpause when you're ready to discuss. So I've got a lot going on here, so let's see what we've got. All right, so for number 1, f of x, I have x equals 0 and x equals plus or minus root 10. Those are my zeros. 0, x equals 0, had an even multiplicity, which was 2. Just kind of note that. So then the completely factored form is going to be f of x equals 4x squared times x plus root 10 times x minus root 10. So these are all of the factors. Now, how did I get that again? Let's go back. Well, first I set it equal to 0. Then I took out a GCF, which was 4x squared, and I was left with x squared minus 10. Set each of the factors equal to 0. Now here, when I set this equal to 0, well, this isn't very nice, so add the 10, take the square root of both sides, don't forget plus or minus. That's how I got x equals plus or minus root 10. Here I can divide by 4, and then the square root doesn't really matter because it's 0, so I still get x equals 0, but I just know it has a multiplicity of 2. Similar thing over here, set it equal to 0, take out a GCF, 2x to the third, I'm left with x squared minus 7, set each factor equal to 0. Here I get x equals 0 again. This one has an odd multiplicity because of the 3 exponent, so it has a multiplicity of 3. And here I get x equals plus or minus root 7. So my completely factored form is g of x equals 2x to the third times x plus root 7 times x minus root 7. Now, the reason why, well, remember at the beginning, I talked about irrational zeros. And coincidentally, not coincidentally, we got irrational zeros for some of our zeros on both of these problems. What do we maybe notice about them? Well, since this is a video and I can't hear you, you can only hear me, I'm going to kind of lead you into this. Notice that when we were finding our irrational zeros, we always had to do plus or minus because we were always taking a square root. What does that mean? Well, that means that they always show up in what we call conjugate pairs. So if I know root 10 is a 0 of a polynomial, I know the negative root 10 has to be a 0 of that polynomial also. If I know root 7 is a 0 of a polynomial, I know negative root 7 has to be a 0 of the polynomial as well. And vice versa, right? If I know negative root 7 is a 0 of a polynomial, then I know positive root 7 also has to be a 0 of the polynomial. And here's that phrase that I just said, conjugate pairs. So it's when we have two things that are exactly the same, but with opposite middle signs. And we saw that when we factored, anytime we factored the difference of squares, we always created conjugate pairs. Okay, so this leads us to what we call the irrational conjugates theorem. It's really just saying what I just said. It's just more formal. You don't need to necessarily, well, you don't need to memorize the formalness. You just need to understand what it means. So let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that root a is irrational. If a plus root b is a 0 of f, then a minus root b is a 0 of f. And so here are some examples. If I know root 2 is a 0, I know negative root 2 has to be a 0. If I know negative root 3 is a 0, I know root 3 is a 0. If I know 2 root 7 is a 0, I know negative 2 root 7 is a 0. Now here's where it gets a little bit messier, potentially. Not really, hopefully. Because remember, the conjugate is the same but opposite middle sign. So if 3 plus root 5 is a 0, then 3 minus root 5 is a 0. If 5 minus root 11 is a 0, then 5 plus root 11 is a 0. So notice that the 5 was positive in both of these. The 3 was positive in both of these. If negative 7 plus root 6 is a 0, then negative 7 minus root 6 is also a 0. So notice the negative 7 sign didn't change. So these are conjugates. That's what we want to understand about irrational roots. Also notice these were all square roots. That's not going to be a huge deal for this class. Just, from a mathematical point of view, that's an important thing to note. Okay, so this is helpful because if I want to actually write a polynomial, right? So here, write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the zeros 3 and 2 plus root 5. Well, so if I have a 0 of x equals 3 and x equals 2 plus root 5, then by what I just learned on the previous slide, I know that x equals 2 minus root 5 also has to be a 0. So then my factors would be x minus 3, x minus 2 minus root 5, and x minus 2 plus root 5. So my polynomial of least degree that has rational coefficients is going to be this. Now we could actually get this into the standard form if we wanted to multiply all this out. That's going to be more work than we're going to do right now. Questions on that though? Okay, so here, similar sort of problem. I want you to try this on your own. Write the polynomial of least degree that has rational coefficients and this information. Pause the video. Unpause when you're ready to discuss. Okay, so here we end up with 0 of x equals 4, x equals 1 minus root 5, therefore we know x equals 1 plus root 5 has to be a 0. We know that's what we learned. If you're confused on how do I know that, that's what we're talking about. That's how we know it. So the factors are then x minus 4, x minus 1 plus root 5, x minus 1 minus root 5. All right, so to wrap it up, irrational roots come in conjugate pairs. That's important for us to understand, that we always know those are going to come in pairs. And specifically, again, we're talking about square roots. Use your calculator to help you find zeros. We're going to see that a little bit more in our next video. But that's just something to keep in mind, that we always want to be able to understand how we can use our calculator and or Desmos to help us get started in finding zeros. It's not going to help us really with the irrational roots as much, but it still is a good tool to make sure we understand how to use.